And welcome once again. We're looking at multiplying and dividing our radicals. Last video we added and subtracted. So we still have to remember all of our adding and subtracting rules, as well as the rules and properties that we learned previously. So remember that if something is inside a radical, it can only be combined with something that's inside a radical. If I'm going to add or subtract, they have to be like terms. This first problem is all multiplication. The 3 and the 5 just need to be multiplied. And then I have a square root of 2 and a square root of 6. So they can be combined because they're both underneath the square root to make a 12. Now this would normally be finished, except that now that I've done that, I see that inside that 12 there's a 4 and a 3. Well, the 4 is a lucky dude because he can come out of that prison. When he does, he's a 2. And he combines with that 15 to make a 30. And what's left? Well, there's a 3. That's the answer to that first one. Let's look at this second one. I kind of try to look at what's inside of here and see if anything can be combined. The square root of 6 can't be reduced, so he's done. This 2 square roots of 2, they're done. I can't do anything with what's inside here. They won't simplify. But I can distribute this square root of 3 to both those two and just see what I get. They're both inside the radical, so the 3 and the 6 are going to make an 18. Minus, now the 3 can only combine with this 2 that's inside the radical. This 2 that's on the outside, he stays. But when that 3 combines with the 2 inside the radical, that's a 6. And so far, so good. That doesn't simplify. But this guy right here, well, that's a 9 and a 2. And we all know that that 9 comes out because he's perfect. When he comes out, he is now a 3. What's left is a square root of 2 minus, and nothing happens to this 2 square roots of 6 because he was as simple as he could go. And that's all we can do with that guy. Let's look at another couple of them. All right. They get messier and messier as we go, don't they? Okay. So what I'm going to do is look to see if anything inside can be simplified. It can't. So I am going to take this 3 here, square root of 3, and I'm going to multiply it by both of those two guys. And then I'll take this square root of 5 and multiply it by both those two guys because I'm going to multiply everything inside of one times everything inside of the other. In other words, I'm going to FOIL it, as we like to say. So the square root of 3 times a 2, they're not on the same playing field, so that's just a 2 square root of 3 because that 2 can't go inside. The next thing is square root of 3 times the square root of 3. Well, that's a square root of 9. That's going to simplify to just a 3, but I'll write it like this for just a minute. Then I have square root of 5 times 2. Not in the same playing field, so it's just 2 square roots of 5 because can't combine anything in there. Then square root of 5 times the square root of 3. They're both inside that jail, so when they combine, 3 times 5 is a 15. Only thing that really simplifies, because I don't have any like terms, is this guy will be a 3. So let's write this down. 2 square roots of 3 plus 3 plus 2 square roots of 5 plus the square root of 15. That sucker's done. You can't do anything else with that. Let's look at this next one. I have the square root of 3 plus x times the square root of 3 plus x. This one is probably one of my most commonly missed problems because it means this thing written twice. And here's what it looks like. Some students will mistakenly just square each term, but you have to remember that when you're multiplying, you've got to do each term times the other. So the square root of 3 times the square root of 3 is the square root of 9. They're both in the jail. The x is not inside a radical, so he's just going to stay outside and be x square roots of 3 plus, same for this next multiply here, x square roots of 3. And then plus x times x is x squared. I can simplify this somewhat though. That guy's a 3 plus, if you'll notice, these are exactly the same. So I could just say that I have 2 of those crazy things plus x squared. And that's as simplified as this one will get. So we need to look at another couple of them. All right, I like to write these out when they have a square on them so that I don't miss a term, because that is one of the most commonly missed things. And this one's got a crazy x plus 2 inside there, so that is kind of messy. So I'm going to multiply this entirely out, and when I multiply this times that guy, what I end up with is the square root of x plus 2 quantity squared. All right, that means what I'm going to end up with there is just a plain old x plus 2, which is really cool. Now I need to finish this. I'm going to go from here to here, and I'm going to end up with minus square root of x plus 2. Doing this again, but going this way and this way, I'm going to have minus another one of these x squared of x plus 2's, and then a plus 1. And then what I'll end up with, because these two are totally identical, I can write that as minus 2 times square root of x plus 2, because there's 2 of those things, and then a plus 1. And I will have a little simplifying here. You see this 2 and this 1? They'll make 3. So I've got x plus 3 minus 2 times the square root of x plus 2. And that's all that can happen with this one. He is simplified as low as he can go. Now this next guy is something really special. He is what we call a conjugate. And what a conjugate means is you have the same thing written twice, square root of 6, square root of 6, square root of 2, square root of 2, but you have a plus guy and a minus guy, and that's exactly what I have. And something really magical happens when I have this occur. So let's watch what happens. I'm going to do the square root of 6 times the square root of 6, and the square root of 6 times the square root of 2. So that's going to be the square root of 36, which will then be a 6, minus the square root of 12. Then I'm going to have the square root of 2 times that, and the square root of 2 times the square root of 2. So I'll have the square root of 2 times the square root of 6 is plus the square root of 12. And then I'll have minus the square root of 4, which then becomes a 2. Notice minus square root of 12 plus square root of 12. And all I have is 6 minus 2, which is 4. Look at that. That messy old thing ended up being a 4. Nice. Now we can use that conjugate stuff that we just did to simplify each of these. Remember that we don't like square roots in the denominator? So what you can do is you can multiply top and bottom by the conjugate, because that magical thing will happen. So I'm going to multiply top and bottom here by square root of 3 minus 1. Same thing, but I need the minus guy to make the magic happen. And if I would have been given the minus guy here, I would have put a plus guy over here. So you need a minus guy and you need a plus guy. So now what you're going to do is you're going to multiply. You're going to take all of this times all of that, all of this times all of that. So kind of lengthy little process. But the first thing, I'll just leave this 2 out here for now, just in case I need to factor. I'm just going to leave it like that, and we might get to see why and we might not. Just depends. We'll see. Square root of 3 times the square root of 3, that's going to be the square root of 9 minus the square root of 3 plus the square root of 3 plus 1. So this is going to be 3 You're gone, little bud, plus 1. This is going to be a 4. The reason why I left that 2 out there is because there are some times when things will cancel. You'll be a 1, you'll be a 2, and then I didn't have to like multiply it and then factor it again because I saw that there was a 2 in everybody. I just got to leave it. So what I have left is this. And that's all done. And we will be using these when we're working with quadratics here in the next few weeks. So be sure that you're getting a firm grasp of these square roots so that you won't be confused when we're doing more with them. All right. Once again, I'm going to multiply by the conjugate. The conjugate, since this is a plus guy, I need a minus guy. So, kind of long because I'm going to have to multiply each one here. It's going to be messy. All right, so let's see what I have. This is just going to be a messy problem. Square root of 5 times the square root of 5. I'm going to be doing, let's say I'm going to be doing this and then this. So let's write down what I have. Square root of 5 times the square root of 5 is square root of 25, which is 5, minus 4 square roots of 5, using everything that we've learned so far, plus 2 square roots of 5, minus 8. Ugh. Then look at the bottom, doing the same thing again, square root of 5 times the square root of 5, that's 5, because that's the square root of 25, minus 4 square roots of 5, plus 4 square roots of 5. Now that makes me happy because that stuff just drops. Minus 16. So let's see what I have when I simplify here. Notice that the 5 and the 8, minus 8, they will combine to be making a negative 3. I have minus 4 of those things plus 2 of those things. That's minus 2 of these square roots of 5. Then in the denominator, I'll have 5 minus 16. That's minus 11. This is a fine answer, and it works well. I can't leave it like this because I know that it could be cleaned up by multiplying top and bottom by a negative 1. So it's very compulsive. I want it to look as clean as possible. So this would be 3 plus 2 square roots of 5 over 11. And there's my final answer. All right. Now, if you guys need any help, please email me. Be glad to help you. Have a wonderful day.